Hi friends, welcome to Embedded C. In this video, we will understand the CAN message frame format. This is the third video of our CAN protocol tutorials. If you haven't watched our previous videos about CAN protocol, there is a link available in the description. Also, a card will appear here. Let's move to this video. Types of CAN frame formats. CAN frame formats can be differentiated as standard CAN and extended CAN. CAN frame. Start of frame SOF. It marks start of the frame. It is always dominant 0 and it provides falling edge for hard synchronization of transmitter and receiver. Identifier field. It is 11 or 29 bits wide and then a RTR bit. This is also known as the arbitration field. It contains the identifier which is used for the arbitration. It doesn't indicate the destination of the message. Instead, it indicates the meaning and content of the message. Also, it helps to decide the priority of the message. A standard CAN contains 11-bit identifier and 1 bit for RTR. So 2 power 11 is equal to 2048. So the identifiers vary from 0 to 2047. Extended CAN frame. In extended CAN frame format contains 29-bit identifier field. So 2 power 29 which is equal to 536870912 identifiers. RTR bit is always dominant 0 for data frame. Next, control field. Control field is 6-bit wide which has DE R0 and DLC3 to DLC0. IDE bit is dominant for standard frame and recessive 1 for extended frame. R0 bit is not used currently and it is only for the future purpose. Four-bit DLC indicates how many data bytes are transferred. You can refer this image to understand how the number of data bytes is varied from 0 to 8. Next, data field. Data field is 8 byte wide. Data field contains the actual information to be transmitted. It varies from 0 to 64 bits. Next, CRC field. CRC field has 16-bit CRC followed by a delimiter. Polynomial generator is used as given here: x power 15 plus x power 14 plus x power 10 plus x power 8 plus x power 7 plus x power 4 plus x power 3 plus 1. Delimiter denotes the end of CRC and it is always recessive. Next, acknowledgement field, ACK field. ACK field is 2-bit wide. It contains ACK bit and ACK delimiter bit. ACK dominant and ACK recessive. It can be defined as TX and RS. ACK delimiter denotes the end of the ACK and it is always recessive. And the final one is end of frame, EOF. We will see the interframe in the upcoming tutorials. We will consider the EOF alone. EOF contains 7-bit recessive bits. It denotes the end of data frame. We understood the standard and extended CAN frame format. If you have any queries or suggestion, please post it in the comments. If you really like this video, please hit the like button. If you want to get more updates or more videos like this, please subscribe to our channel.